Hello, hello everyone. Continue next example for the proving by using mathematical induction. Okay, this example you see gonna have a little bit different from the previous one. Okay, it's still the finite sum anyway, right? But this one's still finite sum. How will you know? Because you know the last term, right? So we call finite sum or finite series. But this time again, we have to prove is true or not, whether or not. But in this case, you see, we go back to previous example. We have like a 1 plus 2 plus 3 plus 4 power 2, right? Which one plus up to n square and equal to this one. So we call this one, like this one, we call this one is a formula, right? So that means sum of this one, like we write down Sn like this, right? Previous example. So in this one means you have sigma n square equal to this one, n plus 1. This one is a formula I think everyone should recall, right? We learned last year when we do the sequence series. But now we want to prove, okay? We want to prove this one. Like a period example, they give us this one. They give the formula say equal to this one. Then we use a 3 steps to prove it. But this time you see this example, they give this one also, they give this one like a sum of this one, Sn, right? Equal to 1 over 1 times 2 plus and so on here on the whiteboard, up to this last term. But they did not give us this one. They did not give us the formula, say sum it up, what the formula gonna be, like this question. We don't have this one. Sometimes we call this formula, sometimes we call sum of the general form or the n term, right? So what the meaning formula, like this one, when you sum it up, for example, you want to find S4, right? S4, that means you have to find the fourth term, the sum of the first four terms. So you replace 4 there. So become 4, 4, right? N equal to 4, replace n equal to 4. So we replace in here, okay? We replace 4 into the formula. So we have 4 plus 1. 2 times 4 become 8 plus 1, right? And then over 6. Then we simplify. This one going to be 4 times 5 times 9, right? Over 6. And then you simplify it. 2, 2, 3, 3, 1, 3. So 3, 2, 6, so become 30, right? 6 times 5. Then you can find the sum of the first 4 terms here. You sum it up. Gonna be 1 plus 4 plus 9 plus 16. So this one gonna be 20 is equal to 30. So that's the meaning here. Okay. Now, before we just use the formula to calculate for the solution, right? But now we want to prove the formula, right? And we want to see the formula is true by using mathematical induction. So now in this example, we don't have formula here. So we have to find out. It's different from previous. Now how we do it. But in this example, they did not, you see they have their own specific pattern, right? When we find out this one, it doesn't, is neither arithmetic series nor arithmetic series, okay? So I mean, neither arithmetic series nor geometric series, okay? So in this case, it's kind of different from previous one. But they have their own pattern, so we have to find out the pattern for this one. Okay, now we take a look how we gonna find it. One first, right? So you replace this one become Sn, n equal to 1 become S1. So equal to what? 1 over 1 times 2. So 1 over 1 times 2 means 1 over 2, right? Right? This one means 1 over 2. And then this one you can see the term 1, term 2, term 3, and so on until the last term. This in the last term we have is the n term here become n times n plus 1, right? So we can observe here from here 1, 2, 3, 4. So that's why they have n here. So this is the n term, right? And this one can start from 2, 3, 4, 5, and so on should be 6, correct? So this become n plus 1. Why n plus 1? Because you start from 2 here. So you have to plus 1. You did not start from the first term is a 1. So that's why you have to plus 1 here. Okay, so in this case, we try to make something like in similar pattern from the question. So let first term we have 1 over 1 times 2, so equal to 1 or 2. So I can break it down, become like 1 over 1 plus 1, right? Try this one first, see? Okay, now if say next one is second term, n equal to 2. So S2 gonna be, that means sum of the first two terms, correct? So become 1 times 2 plus 1 over 2 times 3. Okay, now we simplify it. We simplify it, become 1 over 2, right? Plus 1 over 6, then you find LCM, correct? LCM 2, 6 is what? 2, 3, 6, right? So you simplify, become 3 here, plus 1 over 6, right? So we have 4 over 6. So we have 4 over 6, then you can make a lowest term, right? So become 2 over 3. Now this one again, you see, we try to make it, find out the pattern, correct? So 203, I can write it down, become 2 here, right? And then over 2 plus 1. You know why? Because this one, first one's a 1 here, right? So the top is a 2 here. And this one, I start from 1, and this is a 2, and then plus 1. You see the pattern? It's a kind of, they have pattern, correct? So now we try next one, gonna more clear. If n equal to 3, so S3 here. So then again, that means find the first 3 terms, okay? So become 1 over 1 times 2 plus 1 over 2 times 3. Get from here, okay, from the original question now here, and this second term, third term gonna be 1 over 3 times 4. So plus 1 over 3 times 4. Now this one you do this one again, simplify it, okay? So become 1 over 2 plus 1 over 6 plus 1 over 12. And then you simplify it again. Okay, so now LCM is what? 2, 6, 12, right? So become 2, 1, 2, 3, 2, 6, 12, and then 3 here. Do the short division, okay? So 3, 1, 2, 6. So this one LCM is what? What is the LCM? 12, right? 2 times 3 times 1 times 1 times 2 become 12. So you simplify this one. So this one gonna be, make it 12, right? So then this one becomes 6 on the top, correct? You have to make denominator here become 6, become 12, so times 6. So 6 on the top, and 6 is the time 2, correct? So become, oh no, 6 already, oh yeah, time 2. So 2, and this 12 already there, so you just plus 1. So now we have this over 12, become 9 over 12. Okay, so we can simplify, become 3 over 4, right? Again, you see the pattern. We have 3 at the top. Now this is a 1, this is a 2, this is a 3, right? So we can make it down, become 3 over 1, 2, 3. Then this one should be 3 plus 1. Everyone get it? See, we have the pattern, see that? Now we try one more, and I think that's all, and we can get the formula for this one. So then if n equal to 4, S subscript 4 here. That means sum it up for the first 4 terms, okay? So become 1 over 1 times 2, again 1 over, just say this one, right? Keep writing here, like this one. Plus 1 more, because we need the first 4 terms, so become 1 over 4 times 5. So simplify it again, okay? So become 1 over 2 plus 1 over 6 plus 1 over 12, and then plus 1 over 20. And then you sum it again. Okay, then you know how to do this one, correct? So just do, just because timing, okay? So this one going to be 48 over LCM should be 60, right? Everyone. Okay, we can, okay, do it like that. Do it now. So find LCM again, right? 2, 6, 12. So 6, 12, 20. So 2, 1, 2, 3, 2, 6, 10. Okay. Then 3, 1, 2, and 10. So we have 2, 1, and 5 here. So this is LCM, correct? So this one 2 times 3 times 2 times 1 times 1 times 5, what we have? 2, 2, 3, 6, 6, 2, 12, right? 12 times 5 is a times 5 going to be 60. Okay, so we have 60 here. And so we have 60, and then the top, I think this one, okay. So you can do this one by yourself because I don't want to waste time here. Everyone know how to do. So I leave this one, okay. Now you again simplify it, make it all over term. 48 over 60, we have what? 12, right? 12 for 48, 12, 5, 60. Okay, so we have 4 over 5. Again, you see the top is a 4, so we can leave at the number 4 here. And this one 3 already, so I can make it 4 here and plus 1. You see, we have the pattern here now. Then if this one come, see now what we have here. So you see the last term here, right? I mean the last here. This one, right? And this one, and this one. You see the pattern? So if this one, if we keep sum up to s sub n, right, to the n term, so we can get the formula for this one, correct? You see the top, the numerator is 1, 2, 3, 4. That means the top should be n, right? Over, and you see the font of the first digit here, 1, 2, 3, and 4. Then it's an n again, okay? But then plus 1, plus 1, plus 1, plus 1. So that means this one have to plus 1. So we get it now. If we have Sn from this line, right? Just say from the question, we can get the formula already, correct? So that means the whole thing, when you sum it up like this one, 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 plus 1 over 4 times 5 plus and so on until 1 over n plus 1. Okay, then this one gonna equal to this one. So this is a formula for this summation. Okay, so you can say sigma of this one, sigma of n plus 1 equal to this one. Okay, this is the one we need, and we want to prove this one, say this formula is true. Now we go next step for this one. We get similar like a previous example already. Now this line we need to prove. Okay, we go next one. Okay, so we need to prove. Now we got this formula. Now we're gonna prove by using mathematical induction. So 3 steps, correct? The first step is what? Let n equal to what? Equal to 1, and then you replace in the question, right? So become S1 equal to, right? You can write this one. You can replace here and here, same, okay? So become 1 plus 1, and this one gonna same as this one too. Okay, become 1 plus 1. So then you replace this one is a 1, right? Oh, sorry, here this is a 1. Okay, so 1 plus 1 is a 2, 2 times 1. So we have this one, correct? Times 2. And this is equal to 1 over 2 also. So then this one is true. So this one is true. N equal to 1 is true. Okay, now we go next step. Let n equal to k. Let n equal to k. Then you just replace n with k, right? No matter you see from the equation. So become sk equal to 1 over times 2 plus 1 over 2 times 3 plus 1 over 3 times 4, and so on, okay? Until this one, 1 over k and k plus 1. Replace n with the k, that's all. And this one become k over k plus 1. Okay, so n equal to k is true without proof, correct? So now it's true now from the first step, and then the second step also true. So this one is like a hypothesis, right? Or conjecture. If our hypothesis say is true, then the one we prove is true, then the final have to be true. We learn logic already, right? Okay. I think you guys learn from grade 9, 10, not from me. Okay. So then now the third step, what we have to do? We have to let third step, the first steps is n equal to k plus 1, right? So we have to replace n with a k plus 1. Okay. So now become sk subscript k plus 1. So will equal to, this time you have to replace in here, right? Okay. So sk subscript 1. So you have to replace in here the formula, okay, the formula one. So become k plus 1 over k plus 1 and plus 1, right? So equal to k plus 1 over k plus 2. Okay, so then this one you see, and actually this is the one we need to prove. Okay, this one is the one we need to prove. Okay, this is one we need to prove. Okay. Okay, the next one, then we can, next step is what? Try to use the formula we have, correct? The formula, we have this one, right? Sk plus 1, S sub k plus 1 equal to Sk, right? Plus A subscript k plus 1. Remember the formula we have from last previous example. So now from this one, because we try to prove this one correct, so you have to start from here, right? S sub k plus 1. And this is a formula we're going to use it. Then you can see Sk is what? Sk mean this one, right? The whole thing here. This one, right? Sk, right? So Sk equal to 1 over 1 times 2 plus 2 times 3 plus 3 times 4 and so on, equal to until the last term 1 over k plus 1. Okay, that means this one equal to this one, Sk equal to this thing, right? So I just replace this one in here. Replace this one, okay, to here, become k over k plus 1. And plus, and a subscript 1 means the next term, right? So you have to replace this one. Replace this one for a subscript k plus 1 because to the next term. So replace this k with a k plus 1. So become 1 over k. Okay, replace this k become k plus 1 because to the next term, right? And then this one become k plus 1 and then plus another one here. Okay, so then this one we can simplify it. What we have become k over k plus 1 plus 1 over k plus 1 and then times k plus 2. Okay, you see this, after this one you just simplify, see this one equal to this one or not, right? So we can simplify it. Cm should be k plus 1 times k plus 2, right? So this one LCM time every term on the right hand side, correct? Simplify it. So k plus 1 cut. So we left here the top gonna be k plus 2. Okay, and then plus 1, right? Because it's already LCM. And then over k plus 1 times k plus 2, that's LCM. Then this one you can simplify. by expand this one, expand it, become k squared plus 2k plus 1 over k plus 1 and then k plus 2. Okay, I can write down up here. So what we have finally, then this one you can factor it, right? We can factor on the top, correct? Become, take a look, become k and 1 plus. We need a middle term 2k, so we got 2k. Okay, then over k plus 1 and then k plus 2. Now you see which one we can simplify. This one cut, right? Cut, remove it. So we left k plus 1 over k plus 2. So you see this one same as this one, correct? And this side is what? This side is a sk plus 1, right? So I can write down here, right? So we got the answer, correct? We prove it's true. So our hypothesis is correct. Okay. This one equal to sk plus 1. So this is a proof correct. So after our hypothesis from the first step, second step is correct. Then the third one, we prove it's out equal to what our hypothesis says true. So then it's true. So this is the way how we prove the mathematical induction. Okay, so I think that's all for this example. And this time you can start to practice some question now, and you check in GC. Okay. Okay, that's all for now. See you next time, next class. Bye bye.